Who's new today? Completely new today. You okay? Okay. Thank you. Welcome again. So we're back in a few minutes. We can go. Go ahead. Okay, perfect. We are right on time. So up next, Fisher, a French startup from Grenoble. They have built something most people have never seen before, a flying wind turbine. Using a helium-filled wind, it floats high in the sky to capture strong winds and generate clean energy. Ladies and gentlemen, please welcome Stéphane Vidaillet and Enzo Alfonsi from Fisher. Stéphane, hi.
Hi.
How are you? Good. Mr. Enzo.
Thank you very much.
For sure. Thank you.
Hello, everyone. Very nice to be here. I'm Stéphane Vidaillet. I'm the CEO of Fisher, and I'm very pleased to be here on stage with Enzo, my chief of staff. So we're going to talk to you about Fisher today, because everybody comes here to hear about data centers, robotics, and so on. But we must not forget what powers all this is energy, and we need more energy. So the one important message is the world of AI and technology needs more energy. And the problem is this energy today, we don't have it, or we don't have it as we want it. Renewable energy is either intermittent or not yet available. I'm talking about nuclear. We need 5 to 10 years. And obviously, we don't need and we don't want more fossil energy. So what to do? Well, energy has a solution. We have invented a new way to use wind power, which is available everywhere. And this new way means sovereign local energy, means very low cost in our case, and obviously a renewable solution. So Fisher is reinventing the way to make electricity from the wind. And how do we do that? Well, our invention is called the Magnus Airborne Generator. We're using high altitude wind, and before Enzo goes into the technology of it, the important thing to understand is that we believe it's going to be the next asset class in renewable. So in 10 years from now, when you think about energy, you will think nuclear, PV, and high altitude wind. So now more about the technology itself.
Thank you. So our belief at Fisher is that you do not need to make systems more complex for them to be more efficient. That's why we only have 3 components in our system. The main one is the cylindrical wing, a very big cylindrical wing. This will harness the power of the wind. The second component is the ground station. This is where all the energy conversion is happening. And between them, you have heavy resistance pulling cables. They're going to be pulled by the wing and generate electricity in the ground station. How does it work? The first innovation we bring is the lighter than air concept for our wing. So our wing is filled with helium. That allows it to go up in the sky and float at very high altitude, between 300 and 500 meters. Unlike traditional wind turbine, we're not limited by size. That allows us to catch way more powerful wind and way more consistent winds. The second innovation we bring is how we harness the wind power. We do not rotate the wing. That's not how it works. The wing floats up in the sky, and through the cables, we engage a spinning. Because we have a wing spinning, a cylindrical object, and we have some wind, there is a physical phenomenon that happens called the Magnus effect. The Magnus effect is a very strong pulling force that is going to drag our system away, pull on the cables, and be converted in energy in the ground station. You've seen Magnus effect everywhere. It's the World Cup right now. If you watch any soccer game, any curveball, that's the Magnus effect. And it's this curve power that we're going to use to generate electricity. Let's see how it works in a quick 3D demo. We have our wing inflated with helium that's going to go up in the sky naturally because of the natural buoyancy of helium. We pilot it by piloting the speed rotation of the wing. With this piloting system, we create an 8-figure shape pattern. This pattern is natural because of the Magnus effect. The way it works is that you will have the Magnus effect pulling our system, generating electricity, and it's going to go crosswind. We're not catching the wind, we're gliding on it. It's like a surfer on a wave. So it's much more efficient and much more powerful. This is a game changer for AI and utilities. First of all, because our system is just an inflatable balloon, it can be scaled to utility scale very easily. Actually, the bigger the system, the better it works. And secondly, we outperform any renewables. We expect a 60% load factor for our system. It is unmatched in all categories. Lastly, of course, we have a simple system and a much more efficient system. So the energy cost that we're getting is below 2 cents per kilowatt hour. This is the lowest cost on the market. And this is because our solution is simple, and it is a new way to catch wind energy. Lastly, it's built for large-scale deployment from the beginning. It's a ground station that fits in a container, so everything is containerized. It's deployed in containers and transported in containers. We don't need any foundations. We don't need to destroy the ground, put something there. It's a plug-and-play system. Lastly, everything is ground operated. Every operations, every maintenance is in the ground station. So you do not need to have highly qualified technicians to see your system work and maintain it. So is that magic? How does it work? We have something simple. We have something less expensive. Well, it's not magic, it's physics. We are the world leaders in a Magnus effect aerodynamics. We are proud to be part of the ANSYS startup program, so we have access to the best solvers in the world to do our research. We are also very proud to have been highlighted as a top use case for the solvers in the Synopsys Converge conference last March in San Jose. So on the software side, we're innovating, but we're also working on hardware very hard. Last year, we deployed our first 15-meter-long prototype, and that was a grand slam in what we wanted to prove. Our system is entirely crash-proof and autonomous from takeoff to landing. This means that from now on, every cent spent on R&D in the hardware is going to be used to progress the science and progress towards a commercial system. Before I give this back to Stéphane, let's watch a quick video of our system flying.
Great pictures, thanks a lot, Enzo. So you've seen the technology as a prototype. Now let's talk very quickly about the company itself. So right now we have this 15 meters prototype. We are working on the version 2 of this to enhance the technology and the performance. In a year and a half from now, we want to have a first commercial product. It will be the Mach 25, 25 meters long, so 100 kilowatt about, and that's for remote sites and SMEs. But the big game changer, the end game for us is the Mach 80. So that's 80 meters long. It's pretty big. It's 10 meters in diameter, and that's a 2 megawatt product, and that's for AI and utilities. And this, we aim to have this on the market within the next 3 years. To do that, we are lucky to have a wonderful team based in Grenoble. We have 5 very experienced founders, 3, sorry, and we have a team of 8 top levels, world-class engineers and doctors. Well, for all this, we need money. So believe it or not, we are starting a fundraising today. And actually, somebody in the room has already invested in our crowdfunding event. So join him. Congratulations, Mathieu. Also, we are looking for larger investors, investment funds. So to summarize and to wrap it up, at Windfisher, we have invented a new way to harness wind energy, and we believe it is tailored, it is very suitable for the AI industrial revolution that needs more power. And it's a local, sovereign source of energy. It's low cost, extremely competitive. I want to highlight it again because I think it's a key point. 2 cents per kilowatt hour, nuclear is about 10 cents. And PV and battery, to compare it, is 6 to 8 cents. So we are multiple factors cheaper than the main sources of renewable energies. And obviously, it's a renewable source of energy. So we believe you should all join us in this seed round, and let's see about it in a year or two. Thanks a lot for your attention.